Algebra 2, here we go, 6.6, rational exponents. Remember from our number classifications that rational means that you can write it as a fraction. Okay? So if I have w to the x over y power, w is your base number. Think of it as like your 2 or your 3 or whatever that's getting raised to an exponent. The top part is your power, and the bottom part is your root. Okay? So the top part is your power, and the bottom part is your root. So, let's just have one here. If I had 2 to the 2/3, that's like having 2 squared and then a cube root. Okay? So if you want to separate those out individually, the top one is your power, the bottom one is your root. Okay, so how do I write out 1/6, x to the 1/6? Well, that's just x to the first power with the 6th root. What do you think about x to the 3/5? Go ahead and think about that. How's that going to be written? Okay, we're going to have x to the 3rd power, 5th root. Not too bad, not too bad. How about we turn it around? X to the 4th root. 4th root of x, that's going to be to the, our power is 1, and our root number, our power is 1, and our root number is 4. Okay, x to the 5th root of x to the 3rd. We'll have x to the 3rd power, 5th root. That's x to the 3/5. With me so far? Okay. Power, root. Power number goes on top. Root number goes on bottom. Power number on top, right, is the power there. Root number on bottom. There we go. So you should be able to do those forwards and backwards. Okay, now we're actually going to solve with it. So 2/16 to the 2/3 power. Okay, so we have been writing it like this. But you can kind of do it in any order. And personally, I think it's easier to go smaller first and then get bigger. But you could do it either way. You could go bigger first and then get smaller. Okay, so if I did it this way first, do the cube root first, go smaller first. There we go, 2/16 to the 1/3. That should be 6. Okay, another way to do it. 3 math x root. See how it bumps it up there to the cube root. 2/16, 6. So now we have 6 squared, 36. Okay? What if we do it this way? 2/16 squared. Well, that's going to be big. 46,656. And then you're looking at that like, whoa, how am I going to do the cube root? That's a big number. Okay, so 46,656 to the 1/3 power. Boom, 36. Alright, so it's a little less intimidating, I think, if you go smaller first and then bigger. But it works out the same either way, so it's up to you. And then if you want to check yourself, of course, you could have just done this right away. 2/16 to the 2/3 power. Ta-da! Fun with numbers. And, of course, what would it be if we just left it stay there at the easy stuff? Let's make it a little harder. Let's make it a little harder. Okay? Our first one that's going to be a little harder is, what if we have a negative up there? 81 to the negative 1/4. Remember what a negative means, to flip it upside down. So now I have 1 over 81 to the 1/4. Okay? And then I could write it with roots if you want, if that helps you visualize it better. 4th root of 81. Okay, remember we can't stop down here with a root on the bottom, but we're just doing this. Maybe this looks a little more familiar to us because we've done it like this before. Maybe you're able to look at this right here and do the 4th root. Okay? Some people might need to write it like this so it looks a little familiar to them. The 4th root of 81. What times itself 4 times gets me to 81? Okay? That should be a 3. Boom. 1/3. Okay, let's think about another way you could do this. You could kind of ignore the negative sign until the end. Okay, you could just kind of ignore the negative sign until the end. The top would be to the negative 1. Let's do the root first. And then do the top. Okay, that could do the 4th root of 81. That's 3. And then 3 to the negative 1 power 1 over 3. Okay? You can do these powers and roots in either order for now. I don't want to say always. There might be a trick example out there that would throw it off, but for the early types of problems here, it appears we can go either way. What about 256 to the 3/8 power? You think about that one for a minute. Go ahead and hit pause. Go ahead and hit pause on the video. You think about that one for a minute. All right. Now, if you're like me, I'm going to try to make that one smaller first. 256. I'm going to go to the 8th root first, and then cube it. 256 to the 1/8 power. Yep, that's going to be a 2. And I'm going to have 2 to the 3rd, 8. If you did 256 to the 3rd power right away, ooh, that's going to be big. But you do the 8th root of that, and it's going to come out as 8. Okay? Seeing how this is going to work today? Alright, we just got a couple more types of problems. They're not too bad. You should be able to handle them okay. Simplifying. What do we do with our exponents when we multiply? X to the 3/7 times x to the 2/7. What do you do there? And this one's a nice one set up for you. I can't promise if they'll all be this nice. You might have to do some math to get a common denominator. Little grade school math there for you, adding fractions. Okay? X to the 3/7 times x to the 2/7. We're going to add our exponents. When we're multiplying numbers, we get to add the exponents. And we'll get x to the 5/7. Like I said, I can't guarantee they're going to be that nice all the time. That might be like a 1/3 and a 3/4, and you're going to have to get a common denominator to add them together. Okay? But you should be able to do that. If a 5th grader can do it, so can you. Alright, z to the negative 5/6 power. Okay, so that negative sign is going to put us 1 over z to the 5/6 power. That's kind of a weird one to think about. Okay, and we said we can't have any roots on the bottom. Alright, so this 5/6 is kind of like a root because we have z to the 5th power 6th root. So we still don't have a nice denominator. So kind of like what we were looking at for last class, what do we need to make this whole? What do we need to make that whole? I need one more 6th. Right? If I have z to the 5/6, I need one more 6th. So we're going to go z to the 1/6 over z to the 1/6. And now I'll have z to the 1/6 over z. Okay? We can't have roots or partial fractions, I guess, there on the bottom. It's got to end up as the whole number. Kind of like what we were working on there in 6.5. Okay, last two problems. Got a little star by this one. This one might be the toughest one of the day. Okay? Might be the toughest one of the day. So, just like up here when we were multiplying, we get to add. Down here when we're dividing, we get to subtract. So this is 27 to the 1/4, and this is 3 to the 1/2. Well, I'd like to subtract those, but like up here, this was an x and this is an x. That's why I got to put those two together. This is a 27 and a 3. Not quite the same. Okay, so if you get one like this in your homework, this could be a bit of a stumper. All right, you're going to have to really think here. 27. Is it possible to rewrite 27 as a 3? Well, 27 is the third power of 3. So actually on the top there I'd have 3 to the third to the 1/4 over, now I have 3 to the half on the bottom. Okay, I can simplify that. Power, parentheses, power, that's when we multiply. So this is actually 3 to the 3/4 power over 3 to the 1/2. And now I can subtract 3/4 minus a half. Okay, so the trick there was that we should be able to rewrite both numbers, okay, using the same big number, the same base. All right, so it's 27. I could rewrite that as a 3 to the third. And then I can, then I can rewrite this power as 3 to the 3/4. So that was the tricky part here, is that you should always be able to rewrite the big number in terms of the small one. Sometimes it might be super tricky, right? This might have been an 81 and a 27. I would have had to taken them both down to 3. So you really got to think on those, okay? So I have 3 to the 3/4 minus 1/2. Okay, common denominator. You can do this. You can do it. Okay, I got to rewrite that as fourths. So that's 3 to the 3/4 minus, how would I write a half in terms of fourths? That's going to be 2/4. Our final answer is going to be 3 to the 1/4 power. And they're going to want us to change it back, if it doesn't come out nice, change it back into the form they gave it to you in. They gave it to us in root form. So 3 to the 1/4 power is the 4th root of 3. Wow, that was fun. Okay? Take a look at that and reabsorb that problem. All right? Changed it to exponential form because it's easier to do the root properties. 27 to the 1/4, 3 to the 1/2. I'd like to subtract those exponents right now, but I can't, okay, because they're not the same base number, not the same big number. Okay, so I had to rewrite 27 as a 3. 3 to the third is 27, so now that's all 3's. 3 to the 3/4, 3 to the 1/2. How did I get that 3/4? I thought it was 1/4. Well, 27 is 3 to the third, and then to the 1/4. So I get to multiply. That's the only time we get to multiply exponents. Power, parentheses, power. 3 times 1/4 was 3/4. So now I have everything as a 3. And I'm going to subtract my exponents right here. Okay? And we'll have 3 to the 1/4 power. Alright? And then it gave it to us in root form first, so I got to rewrite it there. Okay? Last one, and then we'll get you started. Last one here, and then we'll get you started. Okay, we're going to change this into power form, exponential form. This is 64z to the 6th, parentheses all to the 1/3. Okay, and then we're going to distribute this, 64 to the 1/3, z to the 6th to the 1/3. So this is when I would multiply. So that's actually going to be z squared. And the third root, or 64 to the 1/3 power. Okay, 64 to the 1/3 power should be 4. What times itself 3 times to get me to 64? 4 times 4 is 16, times 4 again would be 64. Alright. Boom, there you go. Okay, your homework. And your homework's actually a bit of a thinker as well. Okay, 18 through 60. By 3s. Alright, I'll get you started there. That's 18, 21, 24, 27, 30, ... You can follow that pattern. Your high schoolers, you can count by 3s. You can count by 3s. Alright, we'll have those ready for you tomorrow. Best of luck. If this was too fast for you, all these problems, for the most part, similar ones can be found in your examples in your book. I used a few of the ones there. I also tried to change a few up so you'd have different ones to look at. And this is on YouTube. You can go back and find it again. Handke Algebra 2, 6-6.